So when looking at this, though, from the technical necessity of the process, it's just a technical necessity. I mean, this is, every process model you will look at will include this phase in it. The question is, do we really need this phase in terms of a technical requirement? And actually, I say no. That investigation does not necessarily need this preservation. And I gave this presentation at a workshop once, or one based on this. And I almost got burned at the stake for this comment, because many people are trained to always copy the system. And the point is that we don't really need it for a technical requirement. And the example I kind of use is if we're in an office environment and we go to the break room and someone has taken the last pot of coffee without starting a new pot. There could be 5 of us that go out to try and hunt down this person to find out who it was that took the last pot of coffee. And I'm sure there'll be 5 ways of doing this. Every person does this. We'll go through different ways of trying to find that person. Someone may go through the thermometer to measure everyone's coffee. Some people may just ask around. Some may get surveillance tapes. Some people may lock down the entire building so no one can get out. But the point is that we don't necessarily need to actually lock down the building to find it. I mean, all 5 people could find the same person without going through the same process or locking down everything. So in this case, we don't necessarily need to preserve it, but we risk losing evidence in the process. We risk the person leaving the building and never finding them in the process, but we could also find it without it. So it's not necessarily a necessity. But it is a necessity when we get into forensic investigation. The difference here is that we involve forensics now, we're involving law. If you look at the definition of forensics, it's basically applying science technology for purposes of law, or there's some variation on that definition. So in this case, if we're actually using this in a court of law and we actually want to have this be legal evidence, then we may need to start having our preservation process so we can verify it's the original scene. So in that case, we may need to have our preservation process here for a forensics process. In another example, are bitwise images needed? The DD copy was every single bit from the system was copied over to our file. Is this really needed for a full investigation? If you look at the physical world, when a crime happens in a building, do we take that entire building, bring it to a lab, and keep it there forever? And that's basically what we're doing now with these computers. We have it there forever in case we need to look at it again in the future, or so the defense can look at it, and various things. There isn't as much of an analogy in the physical world with taking or isolating a house forever, of always keeping it isolated for the rest of its existence. So this is kind of a thing that this process is needed because of the current tools required this basically to happen, and it should always occur. But the question is whether this is kind of needed as a long-term thing. And the issue here is legal requirements basically dictate the requirements of this phase. So if you want to define requirements for this for testing or development purposes, it's basically dictated by what the legal requirements and business requirements are more than pure technology itself. And in general, I mean, this acquisition and making copies is very preferred. Don't get me wrong. It should always occur when it's possible, but there's more and more people now who are looking at this. When you look at these terabyte servers or multi systems, it's impractical to make a copy of that entire system and analyze it through. So a lot of corporate environments are looking at this now and reconsidering different approaches to actually doing a minimal acquisition or preservation. So second major area is the actual searching. And the basic point of this is we need our evidence. We need to find that effect object or the cause objects to actually say that this event occurred or not. So the basic goal here is to recognize the objects that may contain information about our incident. So our basic approach here, develop a hypothesis, define what we think the evidence is going to have, and then try and find it. So again, basically the whole searching here hypothesis. So an example before we had with our forged documents. Our hypothesis was that this person was using this computer to develop images or documents that were forged documents. That's our hypothesis. So we're looking for files that match that match this hypothesis, which could be image or Word documents or other documents. So we have to define the characteristics of this evidence. So if we're thinking about a JPEG image, for example, or a Word document, there are certain characteristics of the file that we can look at. So JPEG's the simplest. We'll go for that one. Most of the JPEG files end with .jpg or JPEG as the extension of the file. So a very basic search would be to search the entire computer for all files that meet that extension. Well, it's very simple actually for someone to change that extension to avoid the search being successful. So you can look at the actual structure of the file. If you look at the structure of the file, the first 2 bytes of every JPEG file are FFD8, I think it is, or D9 in hex. There's the same 2 bytes in all JPEG files that match that occurrence. So instead, we can modify our search now to look for all files that begin with, the hex values FFD8 and end with FFD9. And the other characteristics in the middle of the file, such as the actual image as a certain, mathematical relationship to other stuff around us, we can search for characteristics of these files to help us find a specific image type. And we basically go through and compare this with all of our objects in the system. So as an example here, we define our target. We extract all of our data and interpret it out of the system. We compare the two together, and once we identify our actual evidence of the system. So what are requirements in this process here? Well, the first is we must accurately define our target, what we're looking for. So if the computer is allowing us to search for this automatically, you'd be able to accurately define this target based on this. The bigger issue is we need to accurately interpret and extract the data out. This is actually basically what all tools currently do, is they basically take this file system image in and they process it using this proprietary, various formats. So what's required for this? Well, there's basically this process where we have to process the file system or Word documents or PDF files or various other proprietary formats. We need to be able to process them. We need to reverse engineer them in this process. And it basically could be multiple interpretations of that data in general. There's an image I have on the testing site where it's basically there's an NTFS file system and the UFS file system from the Unix world in the same partition. And they both happily coexist, and they're there, and they have their own locations. If you import that into most tools, at least before the image is released, then it almost shows NTFS file as an NTFS file system, and ignore the UFS part of it. So this is kind of the process here. It's not accurately interpreting it because there are actually multiple interpretations of that one file system that can actually hide data in this investigation process. And then the actual comparison process between the target and the extracted data. So what's the existing research in this area? There's actually interesting work by Stollard and Levitt out of Davis, which basically looks at automated analysis for digital forensic science. And this was his master's thesis. And basically the approach here is that we read some log files of a Unix system. So we look at the wtemp file, which basically shows when people logged in from this time to this time. And it goes through this log file, looking at the various log in, log out times of the system, and then it examines the MAC times on the files. So every file has a modified access or change time associated with that. And this tool goes through, looks at when people should be logged in, and compares the actual MAC times on files that are owned by these users to find out whether or not it's reasonable that they were logged in or not. So we may find that if my account was used to be broken in the system, my account was used to break in, they cleared the wtemp file to hide the existence that it was there, but I may have some files under my name that were created during that time frame. So this basically goes through and defines this. So we're using the wtemp file to define our targets, basically based on this data. So we're looking at, files owned by a user carrier and, created in this time range. Most of the work in this area is manual. Basically, it's a manual. I'm looking for, Etsy password files. So I go to Etsy and I go to password. Or I'm looking for, the Internet Explorer history file or cache directory. It's all a basic manual process of finding the target and visually comparing them, not really defining it in the tool itself. Pretty much every malware, virus, antivirus checking tool is basically this process of there's a standard target of we know virus has this signature. Basically, this all or IDS areas are all this area. The extraction process is basically what all current forensics tools do. You give the disk image, you give a partition image, and it extracts out the various data in the various formats. I did a paper on this a few years ago on this process. This is kind of what the main focus of all the current tools are. And the comparison process is pretty visual now, as I said before. You look at a directory, you find this directory name, you open it up, look for this file name. In the last